Nate the Mathematics Guy.
Nate.
Nate the Mathematics Guy.
Hello everybody. I apologize in advance if I sound a little bit hoarse. I'm still recovering from a cold/flu. But what I thought I would talk about today is what is known as the Dragon Fractal. There was a previous puzzle that I put up on my whiteboard, and what that puzzle was turning into is what is known as the Dragon Fractal. So here's a picture of the Dragon Fractal in black, and the Dragon Fractal is composed of two smaller copies of itself. Those are shown in red and blue here. So here's one way that you can think about it. There's a paper folding analogy. So imagine you have a sheet of paper, and you have folded it in half many times, and you decide to start unfolding it. So first you unfold it once to a right angle, and then you unfold it again, always unfolding from the right-hand side of the paper, and then you take that and you unfold it again to a right angle, and each time you unfold it you also rotate it counterclockwise 45 degrees, just so that it's in the same place where it started. And you keep doing this over and over again. Pretend that you had folded the paper infinitely many times. You keep unfolding a new copy and a new copy, and in the end, this is what you get. I've used color to illustrate some of the internal details of the fractal here. It's a really beautiful fractal. Now I'm assuming you don't actually have a sheet of paper that you can fold in half infinitely many times. So here's another thing you can do. Let's start with a couple of isosceles right triangles, one exactly half as big as the other, and then extend the sides of each triangle an equal length to the leg of the triangle, and then go ahead and make those extensions into the hypotenuses, hypotenusi, I'm not sure what the plural of hypotenuse is. Turn each of those into the hypotenuse of a new isosceles right triangle. That's a triangle with 90 degree, 45 degree, and 45 degree angles. And just keep doing that. Keep extending the shorter side of the triangle by an equal length, and then making that into the hypotenuse of a new triangle, etc., etc. And then I'll come over here, do the same thing. Extend the shorter side of the triangle, make that into the hypotenuse of a new triangle. So each time your triangles are getting smaller by a factor of the square root of 2. And you just keep doing this, and what you get is these couple of spirals. Okay. Next step, you're going to take the hypotenuse of the big triangle here and go ahead and divide it into fourths. I'm just kind of eyeballing it here. And when you've divided it into fourths, draw a smaller isosceles right triangle whose hypotenuse is half as big as the bigger triangle. And then you're going to draw a bunch of these lining the inside of the spiral. So I call these the small teeth of the spiral. And then you go to the other spiral and you do the same thing. You give it small teeth around the inside. Notice the middle big triangle actually has two teeth poking out of it now. And it's supposed to. Okay, next step. Mark approximately halfway along the edge of the big triangle and extend the other edge of the big triangle upward. And draw a hypotenuse, so you have a isosceles right triangle. Then divide its hypotenuse in half and put another right triangle on top of it. and then divide its hypotenuse in half, put another triangle on top of it, and you see you get a spiral this way. Each time you build another triangle on top of the previous triangle, and you can go as far as you care to until it gets too small to really draw. So you're constructing these spirals. And of course you do the same thing over on the other side. Now, for more fun. Next, what you need to do is we'll come over here and divide this side of the triangle into quarters. So this should look familiar to you. And then we're going to put another triangle on it. So it's taking up half of that edge. And just line all of the inside edges of the spiral with little teeth. Okay, so once you have the little teeth lining the edge of the inside spiral, then you take the outside spiral. And these teeth, I call these big teeth, because they line the entire edge that they're glued to. Here's a more computer-generated way to see it if that doesn't help you. And I got bored and I didn't want to draw the whole thing. See the inside and the outside teeth, and then each of them you make into a spiral. Each spiral you line with small teeth around the inside, big teeth around the outside. Turn each of those into a spiral. And lather, rinse, repeat until you're satisfied that you've done this to as much detail as you care to. And voila! There you have the fractal. And here I'm showing in red that this really is the same fractal that you get from the paper folding. So you just keep folding that paper over and over again, unfolding it to a right angle, and the two become the same shape in the end. I don't actually know why this is, by the way, but I'd be interested to find out. This is Sierpinski's triangle, and there are all kinds of other fractals. This one is made out of 3 copies of itself. Just do a Google search for fractal art and you can find all sorts of incredible fractal images.